Today, we're going to look at powers and exponents, and we're going to start off with a review concept to help us introduce this concept for today. So, first of all, what is multiplication a shortcut for? So, for instance, a long time ago, when you did like 2 times 3, this was a shortcut for 2 plus 2 plus 2, or 3 groups of 2. So instead, you took 2 times 3 to get to your answer faster. And that's basically what exponents and powers are for, except for it's repetitive multiplication, whereas multiplication was repetitive addition. So, looking at exponents, that's the little number that is in the right-hand corner. That's your exponent or your power, and the large number is your base. That's the factor, that's the number you're going to be multiplying. And then the little exponent will tell you how many times you're going to multiply that base. So for instance, this doesn't mean 3 times 2, this is 3 times 3, or 2 factors of 3, which gives me 9. Okay, but we're going to kick this up a little bit, we're going to deal with some integers here. There we go. Alright, so exponents with an integer base. Alright, so we can start off very basic. We look at simplifying a 4 to the 3rd power. That means 4 times 4 times 4. And you can just go down the line. 4 times 4 is 16, and then 16 times 4 gives me 64. Alright, there we go. Okay, now if I look at b, I have negative 2 to the 4th power, and that negative 2 is in parentheses. That's going to be important for us. That means I take the whole quantity 4 times. So negative 2 times negative 2 times negative 2 times negative 2. Now you'll get to the point where you don't have to write all this out. You might already be there already, but I'm showing you this for a reason. And as we go down the line here, we have negative 2 times negative 2, that's positive 4. And then 4 times negative 2 gives me negative 8. And then negative 8 times negative 2 gives me positive 16. So that comes out positive. Okay. Now looking at C, we have the same base, negative 2 to the 5th power. And we're going to find out that this is a little bit different. So basically it's going to be this same thing, 4 negative 2's, just like we did here, but we're adding on a negative 2 to the end. Okay. So remember, we already did this. All the way through here, we got positive 16. But now we're going to take 16 times 1 more negative 2, and we get negative 32. And here's what I want us to note at this point. If you have a negative within parentheses to a power, you're always going to get, if you have a negative to an even power, negative to even power, that's going to give you a positive answer. If you have a negative to an odd power, you get a negative. This is every time. Okay? Whenever you have that, so we could have negative 1 to the 100th power. Well, that's going to be negative 1 times negative 1 times negative 1, 100 times. So I know that this is going to come out positive because this is an even power. That's 1. But if it was negative 1 to the 1001 power, this I know will come out negative 1 because that's to a odd exponent. Okay, so shortcuts that we can take there. Now the last piece that we need to note is letter D, and this one's a little bit funky because we have no parentheses this time. Whenever there are no parentheses and there's a negative sign, this will always come out negative because we could rewrite this just like this. Negative 1 times 2 to the 4th power. And anything times negative 1 will always be negative. So this is not being applied by this, okay? If the parentheses are there, then it's telling you, okay, this power at this point in the game. So we'll talk more about this tomorrow. And that's all I've got for this video. And then the next one will be much shorter with fractions as a base. All right.